Hello and welcome back to Apt4U. In this particular video, we will continue our discussion on the 01 knapsack problem. So if you remember, in my previous video, I have already discussed about what 01 knapsack problem actually is and how we can basically solve the 01 knapsack problem. So we discussed few aspects, that is, what was the 01 knapsack problem. So we have discussed about this, the 01 knapsack, and how is it actually different from the fractional knapsack. So we discussed this thing, isn't it? And then in the previous video we finally discussed the recursive approach to solve this particular problem, the recursive approach to the 01 knapsack. So the prerequisite of this video is, please watch my video on the 01 knapsack solved using recursion. So I'll provide the link to this particular video in my description, right? So just to get an overview and revision, just for the sake of revision, I will explain how actually I basically solved the 01 knapsack using recursion. So what was the process? Now we knew that whenever we are to solve a 01 knapsack problem, we are provided with two type of arrays, right? So I'll be just starting from scratch again. So you have one array basically called val and one array basically called weight. So this basically weight indicates the weight of the items. So you can see here all the items have equal weight, 1 kg, 1 kg, 1 kg, suppose. And val basically means the cost associated with each item. So the cost associated with each of these items is 10, 20 and 30 respectively, right? And what does W indicates? W indicates your knapsack capacity. So the capacity of the knapsack initially here is 2 kgs, right? So I hope you're getting my point. You are now provided with a knapsack. The knapsack capacity is basically 2 kg, means you can only store 2 kg of any items in this particular bag. What is the objective of the problem, 01 knapsack problem? The objective is you need to maximize your profits, means which items will you pick from here such that you can make full use of your knapsack, and at the same time you will have your maximum profit. We already discussed this in our previous video, isn't it? So clearly you can see that I have an array like this is my item. Suppose items are A, B and C, and the weight of each item are 1, 1, 1, and the value associated with each of them is 10, 20 and 30 respectively. Now if I say you that my capacity of the knapsack is 2 kg, which of these items do you think you will take so that you have maximum profit? So definitely I will be picking up item C and item B because their profit associated with them is maximum, and it will give me a profit of how much? 50 kg. What if I take item A and item B? So if I take only item A and item B, I will basically use 2 kg. My capacity is 2 kg, and profit in this case will have only 20 plus 10, that is 30 kg. So it indicates that I have not made the full use that I could have made. So what is the best combination that will yield to maximum profit? Definitely item B and definitely item C, these two, right? So we will not pick item A, we will pick item B and C. That will give me maximum profit of 50 kg. Now how did we discuss about solving this particular problem? So we knew that we are going to use recursion to solve this particular problem, right? The corresponding code I have written here. So what was the approach? The approach was quite simple. What did we do was we just considered the array. The array was basically like item A, item B, item C. This was the weight array, this was the value array, and weight was 1, 1, 1, no problem. The profit associated with them is 10, 20 and 30. So if you remember the previous video, what did we discuss? We are traversing from right to left, means the rightmost item you will be considering first, and slowly you will be just moving towards your left. So what does it mean by considering the rightmost element? So basically if you just look at the index is basically like the index is 0, index 1, index 2. So if n is equal to 3, we basically are pointing to n minus 1 first. Okay, n minus 1 index is the last element. Index equal to last element, isn't it? So suppose I am standing in front of this element. Suppose I am in a shopping mall. I am a thief. I have a knapsack of capacity 2 kg with me, and now I am just standing in front of this item. What is item? Item C. Suppose this is placed on the shelf. Now I know that the item C has a weight of 1 kg and its profit associated with it is 30 kg. Now it is upon me to decide whether I will pick up this item or not, right? Don't you think so? So obviously if the weight of this item is less than the capacity of the knapsack, then definitely I can either pick the item or I can leave the item. That is upon me, isn't it? So what do you think we will do here? Whenever we find out that the weight of the item is basically less than the capacity of the knapsack, I have two options. Either I will pick it or I will ignore it. So if you pick it up, what if I pick up this item? If you pick up this item, what will happen? What are the changes that you will observe? Definitely this item, when you pick up, it will be put in your knapsack. Once it is put in the knapsack, the capacity of the knapsack will decrease, isn't it? So capacity means when you pick up an element, what are the changes observed? First thing, capacity of knapsack will decrease. Second, your profit is going to increase, right? You will add some amount to it. So how do you actually code? So here we see. Now, how was the base condition designed? So I hope you are aware of how was the base condition designed in the previous video. Now what is the base condition indicates? Now you know that this particular function is basically targeted to find out the profit associated, right? So now we know that whenever n is equal to 0, means whenever there is no elements at all in the shopping mall, you just enter the shopping mall to rob something, but you see that the shopping mall is completely empty. There is no items in the shopping mall. What will be your profit? 0, isn't it? Because I will not be able to take any items. Or you entered the shopping mall but your knapsack is already full with many items. That is, the capacity of the knapsack is 0. So in that case also, if the bag that you are carrying on your shoulder, is already full with items, then what do you think will be the problem? The problem is I will not be able to accommodate any more items into it, right? Because the knapsack is full. Now how do you indicate knapsack is full? If the knapsack capacity is indicated by 0. So this clearly indicates that whenever either of the condition is true, which means either the no items are present, means either the shopping mall is completely empty, or your knapsack is completely filled, or your knapsack does not have any capacity left. In that case, the profit will be 0. So remember, this is my base condition. What is the other case that can happen? The other case that can happen is you enter the shopping mall and the object that you are looking at, suppose there is an object on the shelf, you are standing in front of it, you are looking at the object, and now you see that the weight of this object is very high than the capacity of the knapsack. Suppose your capacity of the knapsack is 2 kg and you find out that this object weight is 10 kg. Do you think you can accommodate it in your 2 kg knapsack? So no, right? So that is why I have written here weight n minus 1. Now why I am writing n minus 1? I just now explained. If n equal to 3 is the total number of items, the last item will basically be at index n minus 1, right? The last item is at index n minus 1. You can see at index 2. That is why I am writing n minus 1. And remember, I am always starting from the rightmost element and then I am slowly moving towards the left. So first of all, I am standing in front of an element, and if I find out that the weight of the element is greater than the current capacity of the knapsack, which means you cannot include that element in your knapsack. So what will you do? You will simply reject this element and move ahead. So move ahead means now you will consider the remaining elements, excluding this element. So now, if I reject means this condition. This means rejection. Okay, so sorry for that. Let me just explain you this part only. So right now I am explaining what? This part. Whenever you find out that the element's weight is more than the capacity of the knapsack, so what do? You reject. So this is how I reject. How do you reject? You see, there will be no change observed in the capacity of the knapsack. Why? Because you have not included this element in your knapsack, right? You have not included this element in your knapsack. So basically the capacity of the knapsack remains the same. So W only. You receive W, it will remain W only. The weight array and the value array will remain unchanged. One change that you will observe will be the number of items. Since you are ignoring this item at this point, so basically you are not going to consider this anymore. Means now you are going to focus on the remaining elements. So the number of items from 3 reduced to how much? 2. That is why I am writing n minus 1. So remember, this is the case when you are rejecting an item due to overweight, right? Now what is the next point? The next thing that can happen is, so this was the basic case that can happen. The first case that can happen is your item's weight is more than the capacity. Or what if the item weight is within the capacity? For example, in this case, what did we see? In this case, we just saw that, right? So this was basically 1, 1, 1. This was the item weight. Element A, element B, element C. So suppose right now I am standing in front of element C. Why? Because I said I am moving from right to left. So you are standing in front of element C. Now you find out that the capacity of the weight of the element C is basically less than the capacity of the knapsack. What is the capacity of the knapsack? 2 kg, isn't it? So basically you can clearly store the element in your knapsack, right? 2 kg knapsack and 1 kg is the weight of this element. So now you are thinking, what you are thinking, whether I should pick this or not. So you have how many choices? 2 choices. So else, that is why I am writing else, you have 2 choices, right? Means whenever, else means what? If your weight is greater than 0, greater than the capacity of the knapsack, you are ignoring. But if your weight is less than or equal to the capacity of knapsack, means you have 2 options. What are the 2 options? Either you pick up or you ignore or reject. So what if I pick up the element? So now you know that, as I explained, if you pick up this element, C, what will happen? What are the changes that you will see? The changes that will be seen is the capacity of the knapsack will be reduced. By how much? I will subtract the weight of that element from the capacity of the knapsack. So you see, capacity of knapsack minus the weight of the element that I have picked up, which was at n-1 position. And any more changes? Yes, one more changes is the profit will be increased. So basically you see, I am adding profit, and I am then calling the knapsack function by reducing the capacity of the knapsack and reducing the number of elements also. So one more change is the number of elements is decreased. So obviously you picked up this element, so the number of elements now reduced to 2 only, right? So you can clearly see this is a particular expression for the case when I am basically picking the element. So when you are picking the element, you are basically including its profit, the cost associated with it, you will get the money for that. Plus now you are just trying to reduce the problem to what? The same knapsack function, and you see the weight of the capacity. The capacity will basically be reduced, isn't it? By how much? By WTN minus 1, and the number of elements also reduced. Rest, the weight array and the value array remains the same. So what are the changes that you see? The changes that I observed was on the capacity of the knapsack and the number of elements that I am considering. These two are basically dynamic in nature. They are going to change, isn't it? But the weight array and the value array remains the same. And what was the other option that I can do? The other option was I can simply reject the item. Means I am standing in front of 30. Although I find out that the weight of this item is less than the current item capacity of the knapsack, because item weight is 1 kg, capacity of knapsack is 2 kg. I could have picked up, but I thought that okay, let us ignore this. I'm not interested in picking this. So if you're just going to ignore it, what is the changes that you are going to see? The changes that I'm going to see is basically the capacity of the knapsack remains the same. These and these are always same, and the number of items are only going to get reduced. So you see, this expression is same as this expression, means the rejection expression. Don't you think so? This and this expression are same for rejection, means whenever you are rejecting any item. So likewise you can see that this is how the recursive code was written, right? The recursive code was written. So I hope you are getting the point. Now, what was the intuition behind this? So let me just explain you the recursion tree. So the problem that I picked up right now was what? That you have basically a value array with items 10, 20 and 30. You have a weight array with items 1 kg, means all the weight of all the items are similar. Now as per our recursion, how will the recursion tree look like? So I have just picked up this particular image. So let me just explain you how it is actually working. So this image has been picked up from Geek for Geeks because I found that it is easy to explain via this particular image. So suppose this is the value of the knapsack that is given, means I'll be writing here value, and I have 10, 20, 30. The weight given are 1, 1, 1, and this is item A, this is item B, item C, and the index is 0, 1, 2. Now as you know, I am a thief. I just entered inside. Alright, now I basically, what will I do? I will stand in front of this item. Which item? The rightmost item, the last item, okay, whose index is 2. Now this is only index, okay, this is the index. So index 2 item is nothing but item C. So I am standing in front of it. What is the first thing that I will see? I will call the knapsack function. I will pass this value array, I will pass this weight array, and I will pass the capacity of the knapsack, which is 2 kg. Initially my capacity of the knapsack is empty. Now the very first thing I will check is whether there are any items in the mall or not. So definitely I can see there are n equal to 3 was passed. So basically there are 3 items. So it's good. Is the capacity of the knapsack 0? No, because the capacity of the knapsack is 2 kg. Means this will not be executed. What will we check next? Next I will check. Now the item which you are in front of which you are standing is item C, right? So you will check that whether the weight of this item is less than the capacity, greater than the capacity of knapsack. So do you think the weight of this item is greater than the capacity of the knapsack? False. Why? Because it is 1 kg, then capacity is 2 kg. It is less, not greater than. Fine. So this will not be executed. Come inside. Else, what are the choices you have? Else it indicates that the element weight is less than the capacity of knapsack. So whenever you find out that the element's weight is less than the capacity of knapsack, you have two options in your hand. What is the option? Either you pick up or you reject. So you can see similarly here, I have 3 elements with me. The capacity of knapsack is 2. Right now I am standing in front of this element. So what will happen? I can either pick up or I can reject. Suppose I rejected or I picked up. Now if you reject, okay, if you reject, so what are the changes that you are going to see? If I reject this item, means I have not picked up this item in my knapsack. So definitely whenever you just simply reject the item instead of picking it in the knapsack, you know that W is the knapsack capacity, okay, and N is the number of items. So what are the changes that will be observed when you are rejecting? So whenever we are rejecting, the capacity of the knapsack remains the same. So capacity was 2, it will remain 2. And the number of items will be reduced by 1 because you are simply rejecting this item. You are considering the remaining items. Done. What if you accept the item? What if you pick up this item? So if I pick up this item, which means that I am picking up this item and I am storing it into my knapsack. And when you are storing it into the knapsack, it indicates the knapsack capacity will be decreased by the weight of this item. So if this item weight is 1, the knapsack capacity was 2. So 2 minus 1 is equal to 1. That will be the new capacity of the knapsack if you are picking up this item. Clearly you can see, if I am picking up the item, the knapsack capacity has reduced 1, number of items reduced to 2. So this you can see is this is where I call the function knapsack. Now these are the sub problems. What is the sub problem? These are the sub problems, okay. These are the sub problems, which means it indicates you have 2 items to consider, these 2 items, and the knapsack capacity is 2. So you have to now find out the maximum profit. This again indicates the same thing. You have 2 items to consider. Which 2? These 2. And your knapsack capacity is 1. So what will be the maximum profit that you can incur? So what will you do again? Again you have 2 options. Okay. So suppose I rejected item C. Now you have 2 options. What are the options? I am standing in front of this item now. Okay. Suppose I rejected this. I am standing in front of this. So now either you can pick up this element. What will you check first? Whether items B weight is less than greater than capacity or not. So it is not greater than capacity, right? Because it is less than, which means you can accommodate it in the knapsack capacity. Capacity of knapsack is 2. So again you have 2 options. Either you pick up B or you reject B. Suppose I reject item B also. So if you reject item B, you know that the capacity of the knapsack will remain same. Will remain 2 only. But the number of items has reduced to 1. Means you are not going to consider B anymore. Now you are going to consider only item A. Done. Or if you pick up item B, if you have rejected C, means you have followed this path. You have rejected C, but you have picked up B. So what does it indicate? If you have picked up B, then the capacity of the knapsack will be reduced. So previously your capacity was 2. Since you have picked up B, B's weight is 1. So 2 minus 1 is equal to 1. This is the new capacity. And the number of items is also reduced to 1. Which means now you are going to consider on item A after picking B. And here you are considering on item A after rejecting C and B both. Now again in this point you have 2 options, which means either you can reject item A or you can pick item A. So if I reject item A, okay, if you reject item A, what will be the resultant value? If you reject item A, it clearly indicates now you are going to call the knapsack function on 0 elements with capacity 2. What will be the output? The output will be 0. Why? You know that when n is equal to 0, now this is n, isn't it? If n is equal to 0, the base condition will return 0. It will return 0. But if you pick up item A at this point by using this branch, what will be returned? So basically you can see I have picked up A. Now the capacity of the knapsack, now if you have picked up A, okay, you have picked up means you have followed this case, picked up. So what will be returned? Value of the item, that is 10, isn't it? 10 plus again what will happen? Again it will be calling, let me just show this. So I was explaining that considering this problem where you have capacity 2 and only 1 item left, okay. Now you have 2 choices, either you reject the item or you pick up the item. So if you reject the item, okay, what is the value that you will be getting? 0 rupees. But if you pick up the item, what is the value that you will get? Okay, you have picked up the item 10. So since you have picked up, so basically you are getting the profit associated with it, isn't it? That is 10 rupees. So out of 10 rupees and 0 rupees, what is the maximum deal? The maximum is 10 rupees, isn't it? So this particular function will return a value of 10. What the point? This particular function will return the value of 10. Now likewise, if you consider this case wherein you are basically, you are basically picking up element B. If you picked up element B, right, means you have already incurred a profit of 20 rupees plus. Now you are trying to look what is the maximum profit I can receive from here. So now you have considering on element A and your capacity is 1. So you have two options, either you reject or you pick up A. So if you pick up A, what is the profit you are going to get? 10 rupees. If you reject A, you are going to get how much from this deal? 0 rupees, right? Because you are not picking up A for this function. So 0 and 10, what is the maximum? The maximum is 10. So 20 plus 10, what is the value? 30. So what will this function return? This function will return 30. I hope you got the point, right? Now, considering this deal, what happens here? You picked up item C. If you picked up item C, means you are already have a profit of 30 rupees because item C profit is 30. Plus, now you are looking at what is the maximum profit I can incur from the items A and B given my capacity of knapsack is only 1. So what will happen? Now you have two options, either you pick up B, either you reject B or you pick up B. So if I reject B, the what will happen? If I reject B, simply my number of items will be reduced to 1. The capacity remains the same. Capacity remains same. Item reduced to 1, which means now you are focusing on item A. So now you are focusing on item A. So basically you have two options in your hand. What are the options? Either you pick up item A or you reject item A. So if I reject item A, which means what? The profit you are getting from here is 0, right? But if I pick up item A, you are getting 10 rupees from here, isn't it? Now, which means this deal is basically giving you a maximum of 10 rupees. What about this deal? This deal says that here you have basically picked up item B. So when you pick up item B, which means you have included a profit of 20. So 20 included, plus the capacity of knapsack is 0 and the number of items left is 1. Now you know whenever your capacity of knapsack is 0, you are simply going to return 0. You are not going to accommodate any more thing, right? So from this 10 and from this 0, what is the maximum you got? You got a maximum of, its right wing basically will return a value of 20. Its left wing basically will return a value of 10. So 10 and 20, which is the maximum? 20 is the maximum. So 20 will be returned, and 30 plus 20, what is the maximum? 50 is, 30 plus 20 will give you 50. Now among 50 and 30 from this left wing, which is the maximum? 50 is the maximum. So it indicates that this value will basically be 50 as per this example, right? So this is how the recursion is actually working. Now what is the problem with this particular approach? So alright, so what was the problem actually with this approach? So now we will be discussing what were the problem that was present in this recursive approach. So I hope by now you have basically understood and are comfortable with how recursion is actually helping to solve this particular problem. Now we are going to detect the problem in the recursive approach. So first of all, let us consider what was the time complexity of this recursive approach. The time complexity was order of 2 power n, isn't it? So we know that why it was exponential sort of time complexity, 2 power n. It's very huge, right? And it is not actually feasible solution. We cannot expect such a huge time complexity. We need to optimize it. But before optimization, we should actually point out where is the problem actually lying. So if you refer this recursion tree, you know that what are the recursion calls. So these are the recursion calls, isn't it? So this is the first call I made on the knapsack problem. Now I had two cases here. So this was the knapsack recursion call. Again, this was the recursion call. Again, under this I made this recursion call, this recursion call, this recursion call, this recursion call, and similarly this was the call again. This again was a separate function call. So these are basically sub problems, right? So you can see these are sub problems because you can see the parameters values are actually changing in each and every time we are calling the knapsack problem. The problem is there are certain calls like K11 here also, and you can find K11 here also, right? So there are, if now this is very small example, and hence you can find out that there was some cases like this particular case wherein you were making a recursive call with the same values 1 1, and here also you are making a recursive call with the same value K11. What is the problem with this? The problem is, now if I calculate it for the first time, I know what will be the value of this, isn't it? I know what will be the value corresponding to this particular thing. So again I'll be doing the recursive call on the same function again, K11, with the same parameters. So obviously the structure of this tree, okay, and this tree will be same. Now here obviously due to lack of space I'm just writing about the left wing, but the right wing will also be there with a recursive call on 0, 0. Alright, so you'll find that these two functions are exactly same, and hence they don't have to be evaluated again and again, right? It is unnecessarily, you know, wasting our time, right? And it is unnecessarily increasing our time complexity, wherein the same function we are calculating again and again. So if once we have calculated this function, you know that once you have calculated this function, okay, so it is already traversing a long way and again coming back to give you this answer. Similarly, this also, if you just traverse the recursion tree, it also travel a long way and again come back to give the result of this function. So this K11 and this K11 will have same results only. So why to just waste our time in traversing the entire subtree, right? What we can do? We can do one thing. The first time you are encountering this particular parameter K11, the first time you are encountering this particular function K11, we should basically check whether we have already calculated this value before. If you have not calculated this value before, we will store this value in the table. The next time when you come across this call, now it will check whether this particular function was already calculated before. So here you can see this function was obviously calculated before, and this function has already stored its result in the space in a table. So we can, instead of just traversing the entire recursion tree again, whenever this function will be called, it will refer to the table, take the value from that and use it. So referring to the table to take the value takes less time as compared to, you know, traversing the entire subtree. I hope you got the point. Here is where memoization will come into action. Memoization, we are going to create a table which will basically store the values of the functions that we are calculating. Now how will this table look like? So basically the idea is very simple. In memoization, what we do is basically we will create, first of all we will detect what are the changes or what are the states on which the function is actually depending. You can see at every stage what is happening. We are observing a change in the knapsack capacity and a change in the number of items. So these two things are basically, these are the parameters that are actually changing, right? Isn't it? Whenever we are doing a recursive call, whenever we are doing a knapsack call, whenever we are doing a call on the knapsack function, you will see these are the two parameters basically which are changing. What are they? The capacity of the knapsack and the number of items. So definitely it is sure that my table will be formed by using these two things only. Which two things? So you will basically, in the row side, you will basically say you will have n plus 1 rows. If n is the number of items, what is the n? N value is 3, isn't it? So n value is 3. So you will have 3 plus 1, that is 4 rows. 4 rows in the sense 0, 1, 2, 3, like this. 4 rows because index starts from 0, right? And similarly you will have how many columns? The columns will be equivalent to the capacity of the knapsack. What is the capacity of knapsack? W is equal to how much? Here it is basically 2, right? So you will basically create 2, but you will create 2 plus 1, which is equal to 3 columns. So column 0, column 1, column 2, 3 columns. I hope you got the point. So this is how my table will actually look like. So what next? Now we are going to use memoization to solve this particular problem. What I am going to do is, initially I will basically initialize all these cells with value -1. Now what is the reason behind initializing them with -1? Because I will assume that I have not solved any of the functions. Now how do you understand what is a function? You see, suppose I am talking about this cell. Suppose I am talking about this cell, right? Suppose I am talking about this cell. So this cell is a sub problem in itself. Why? Because you see, this is, the columns are corresponding to weights and the row is basically corresponding to the item. Whenever I say what is the value corresponding to this cell, what will be the value here, it indicates that you are basically trying to find out that, okay, you have 0, 1 and 2, means these items in the mall, and the capacity of the knapsack is 1. So let me explain you how we detect the value of this cell. Yeah, so if I say what will be the value of this cell, so you will find out first of all in which row it is present. It is present in this index, second index, right? So whenever it is now this particular value is 2, so what will you do is basically, let me write here weight matrix, weight array, that is 1 1 1, the value array, that is 10 20 and 30, and the index basically has value 0 1 and 2. Now the 2 here, always remember that 2 here is actually pointing to this index, one less index on this in these arrays. If I am saying that it is in row number 2, it is actually referring to this item 1. So whenever I say that I want the value corresponding to this particular cell, so now it means that your problem says that, so whenever I am in this cell, okay, whenever I am in this cell, my problem will look like I have a knapsack of capacity how much? 1, because you see this cell is under this column. So knapsack of capacity 1, and number of items you have is 2 items. Your value matrix array will be like, 2 means which index? This first index, means you will be taking 10 and 20, all the elements from the starting till this index, 10 and 20. Your weight array will consist of all the elements from this position to this index position, 1 and 1, right? So if you want to find out the value of this particular cell, then you basically need to solve the subproblem, this subproblem. This is your subproblem which you need to solve. What is the subproblem? You have a capacity of knapsack as 1, there are 2 items left, and the values of the items are 10 and 20, and the weight associated with them is 1 and 1. And which are the items? Item is A and B. Remember, item is A and item B. I hope you got the point, right? Because I'm pointing out to this row. This row is in value 2. 2 means you can take only 2 items. Which 2 items? The first 2 items. The first 2 items. Means index 2 means 2 minus 1 is 1. 1 till this index. From starting till this index, whatever items are there, you have to consider those items to find out the value of this cell. I hope you are understanding how this memoization is actually working. Now, how do we use memoization? So before we use memoization, let me just run the code. Alright, so it looks quite shabby. Anyway, so I hope you understood what I'm actually going to do. So now what I'm going to do is basically, when I'll be converting this into a dynamic programming code, and that dynamic programming can be solved in 2 ways, either using memoization, which I'll be discussing now, and top down approach, which I'll be discussing in a new video, right? So how do we solve it using memoization? Now remember, memoization is nothing but memoization means recursion plus table, right? So memoization uses recursion, means we will be using recursion, and also we will taking the help of tables. So recursion means the code will remain the same, we are just going to take the help of table. Now the question is, when are we going to use table? So let me just write the memoization code for this. So before that, let me just rub this. Yeah, so this particular function here, is actually indicating, the normal recursive problem, the normal recursive approach. This is a normal recursive approach. So I hope you have already understood by now how to write the recursive problem. You can see the base condition, the rejecting condition, and the condition when the weight of the item is less than the capacity. I have 2 options, either pick or reject. Now this particular function, this particular recursive code had a problem. What was the problem? That problem is shown in this particular image, that overlapping subproblems exist. Means this k11 is a subproblem, this k11 is also a subproblem. If I already calculate this, I don't need to calculate it again because it will waste my time. Now this is a small subtree, so you found out very small overlapping. But if there are suppose thousands of items, then there are many chances of having more overlapping subproblems. Now these are the overlapping subproblems which is responsible for increasing complexity. How we can optimize it? So in order to optimize it, what we did, we created a table. We created a memoization table. Now how do we write the memoization table? So I'll be just writing the corresponding memoization code. Alright, so this is the problem where I'll be writing the memoization code. Now right now, please note that this problem right now is a recursive problem only. Recursive problem. But now I want to convert it into memoization means I want to solve it using dynamic programming, okay, memoization technique, which uses recursion plus table. So you can see this problem here is exactly 100% same to the recursive problem. So far, recursive problem also uses the same conditions, and this also has the same code. Okay, I have not done any changes so far, but now this is not a dynamic programming code. I want to convert it into DP. Now I will be doing that. How we do? By using memoization. What memoization does? It has a recursive code and it will be using a table. Now what will be the dimension of the table? As I said, n plus 1 and capacity plus 1. So for that, I'll be declaring a table integer, suppose dp, and what will be basically my dimension? As I said, it will be n plus 1 and m plus 1. Sorry, not m, w plus 1, right? Because w is the capacity of the knapsack. So I hope you understood what I am actually going to do here. Remember, I just showed you the table. I'll be creating a table n plus 1 size and w plus 1 size. Why do I do n plus 1, w plus 1? I already explained you. Because if I have 3 items, my index should, if I have only 3 items, right, n equal to 3. If I have n equal to 3, then if I only create an matrix of dp n comma w, what will happen? This will start from 0, it will move to 2, right? But I need it to move till 3. Okay, I need it to move till 3, because this will indicate how many items I have. So basically it should be moving till n plus 1. So I created the matrix. Now you know that after creating the matrix you need to initialize it. So initialize it to which value? -1. How do we do so? I will just using memset, and the array name is dp. What I want? -1. Sorry, dp comma -1, and I want to basically initialize it to size of basically dp. So the entire cells here will basically be initialized with the value -1. Now the base condition will remain as it is. What is the base condition? Says that if number of items is 0 or w is equal to 0, you return 0. Now where is the recursive calls you are making? The recursive calls are being made at this point, that is line number 15, and at line number 19. These are where I am making the recursive calls. Recursive calls. What is the idea of memoization? The memoization says that before you make a recursive call, you see whether that value exists in the table or not, right? So basically, if I am receiving capacity of knapsack as w, number of items as n, I know that my cells basically, if you just create the table, if you just draw the table, like this has n plus 1 dimension, this has w plus 1, right? So basically you know that the cells here corresponds to a sub problem. This will be a solution to a sub problem. Means dp of n w is nothing but will give you a solution to the sub problem, the solution to the answer to the question that you are asking. So what is the answer question I am asking? I am asking that if I have n items right now and my capacity of knapsack is w, then what is the maximum profit I can get? So how will you find it? You will have to look to the cell dp of n minus 1 w minus 1, right? That is the point where you will get the answer. So basically what I am going to do is I will be checking here if, so I'll be first of all checking whether that value exists in the table or not, right? So I want to check whether that value exists in the table or not. So what will I say is, if dp of, you have given me n number of items and you are saying that the capacity of knapsack is w, so I'll look for the answer to this question, whether this is equal to -1 or not, which means whether I have solved this particular problem or not. If it is not equal to -1, it indicates that you already have the answer to this question in the table. So basically you just return dp of n w, right? Because you already had the answer to this question and stored in the table, right? In case, now you know that whenever I am passing these values, parameters, that I have n items in my with me and w is the capacity of the knapsack, you want to find the maximum profit, right? So maximum profit that you can make, and you know that these answers are basically stored in the table. So dp n comma w you just move to the corresponding nth row and wth column, and that particular cell, suppose this point, you know that the answer to this particular problem will be stored here. Now if it is -1, it indicates that you have not solved this problem so far, but if it is not -1, which indicates that you have already solved this recursion earlier, so directly return the value this one instead of calculating it again. But if you find out that the answer to this is not present, then what you do, you basically check this condition. Okay, so if the answer to this question is not present in the table, means I have to solve it. So here you are basically trying to solve it. How will you solve? So you know that the things remain same. If weight is greater than W, you are just going to reject it. Reject it means you are going to make a knapsack call on this function. Now this will basically be stored where? So basically you have to store this, right? So return dpnw is equal to this. Means first of all you calculate according to this condition, you solve this function. The answer of this function will be stored in this table, because right now I saw that this problem was not solved because the value was not value was -1, right? If the value is -1 in the table, it indicates you have not solved this particular problem so far. So you want to solve it. So you want to solve it means you will make a recursive call first. As we know that memoization is nothing but recursive call plus table, use of table. So I'll make a recursive call on this problem. This problem will basically return me some value. That value I'll be storing in this place, right? Same thing here. Return dp nw equal to this. Now why I'm writing it in both places? Because if this condition is true, then you know that the answer to this question dpnw will be solved by this approach. And if this condition is true, otherwise this condition is false, then you know that the answer to this question dpnw will be solved by this approach, by using this sort of recursion calls and finding their maximum. So that is why I'll be writing this 2 times, here also, here also. If this is executed, then the answer will be stored again by in this same place. If this one is executed, the answer will be stored in this cell, right? So that is how we can basically use memoization to solve this particular problem. And you know that this will basically reduce the chance of overlapping, calling the recursive function again and again, right, to a large extent. So before executing this, I would like to execute this problem, simple recursion. So we know that the answer to this question was 50, isn't it? So 1, 1, 1 is the weight, 10, 20, 30 is the items given, value associated with the items, number of capacity of the knapsack is 2. So in this case, if you run it, the answer will be 50. We know that, right? But we know that it has a problem of overlapping subproblems, right? Yeah, so the answer you can see is 50 by using the recursion, but we know that it has overlapping subproblem issues. So what did we do? We used memoization. The only changes that we did was we used a table, right? And we basically try to, before doing any recursive call, remember, before doing any recursive call, we are just initially checking whether the value is present or not. Because if it is not equal to -1, it indicates that you have already computed the value. So you can directly return the value. But if it is -1, then you know that either of the condition will be executed. And based on the condition which you are executing, you just update the value in this particular cell. So that next time when I find out this particular condition, I'll be just returning the value. Getting the point? So yeah, let us now execute this code again. The example is same. The answer should be 50. Okay, so this will be capital W. It's my problem. So let us write it as capital W, because capital W is the capacity of knapsack, right? So this will also be capital W. Sorry. So capital W, and here also it will be capital W. So I hope there is no more issues. So you can see basically by using memoization also you got answer as 50. So the size of the problem was very small, so you can find out almost similar execution time. But you know, whenever you will be dealing with very large number of inputs, in that case you will find out the difference between using the memoization technique and using the normal recursive approach. So I hope now you are very much comfortable in writing this particular memoization code. You see, it is 95% same as a recursive code. Only change is you are just declaring a table, right? And at the same time you are just updating the values if the answer is not updated in the table, right? So this is how we basically solve this particular problem, right? And I hope it answers your queries regarding this particular technique, the 0-1 knapsack problem using memoization. And if you just consider the time complexity of this approach, so remember in recursion what was the time complexity? So in recursive approach the time complexity was order of 2 power n, right? But here you can see in this memoization technique the time complexity drastically reduces to order of the size of the matrix n cross w, isn't it? N plus 1 cross w plus 1, but you can ignore the constants. So it depends upon the size, the number of items cross the number of the capacity of the knapsack w, because we are creating a table, right, corresponding to the number of items and the capacity of the knapsack w, right? And basically we are just trying to find out the solution to every sub problem here, right? And considering the space complexity here, it will be order of n cross w only, because this is the dimension of the table. So you see that solving 0-1 knapsack problem using memoization can be solved in order n cross w, and space complexity also n cross w. So that's all from this particular video. I hope this video was helpful and intuitive. In case of any doubt, please feel free to put it out in the comment section. Just like, share and subscribe. And yes, in the next video I'll be coming up with the top down approach to solve 0-1 knapsack problem. Thank you.